All right, so we're going to go through the review really quickly. I'll be working through the answers. Let's see. We have a string A, snakes are cool, and we ask for its length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our answer is going to be, oh, I don't need to write it down there. I need it over here. 16. What is the output of the following code? Snakes are cool. Index of capital S. That's at position 0. So I'm just double checking my key as I go through. Index of cool. If you look for cool with a capital C in that sentence, you do not find it. So you get -1 as its location. What is the output of the following code? Index of A, starting from position 2. 0, 1, 2. If we start looking at position 2, we find an A at position 2. So 2 is our answer. All right, let's go ahead and move on to the next problems. Looks like we can see those pretty good, so let's go ahead. What is the output of the following code? Compare to A.compare to B. So we got to find the first index that's different. Index 0 is the same, but these indexes are different. They have a different value. So first we have to find out how different they are. So you start counting it on your fingers. B, C, D, E, F, G, H, I, J, K, L, M, N, O. So that should be 14 apart. Now we just got to figure out if that 14 is negative or positive. Remember, when A is alphabetically first, when the left item is first alphabetically, we get a negative. Actually, that one had B was first alphabetically, so the right item was first alphabetically, which means this 14 is going to be a positive. What's the output of the following code? Does ax equal ax? Yeah, it's exactly the same, so we get true. Does ax equal ax? No, they are of different lengths. Even if we're ignoring the case, they have A, good, X, good. One has an E, the other one doesn't. So this is false. All right, let's go ahead and move on to the next ones. What is the output of system.out.print character at position 14? So just so I don't mess up my count, I will double check this one. All right, character at position 14. Ouch. Sporks are sharp. Ah, it's supposed to say sharp, it says shape. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's an R. What character is at position 1? U. 0, O, 1, U. We want a substring from position 7 to 14, but it does not include the second index. It does include the 7. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It does not include that other R. So it should be porks a. So that kind of looks like a G. So porks space A. What is the output of the following code? Substring 3. 0, 1, 2, 3. When you do a substring with only one number, it grabs everything from the letter that you have, from the index that you list, all the way to the end. So it'd be H, comma, sporks are shape. And it would include the exclamation. What is the output of the following code? Does it contain orcs? Yes. The word orcs is in the sentence, so this would be true. All right, let's move on to the next set. Looks like we can get 13 through 15. Does it contain hap period? H-A-P-E. Nope, that would have had to have been a period, so we get false. The red coats are coming. If we wanted the uppercase form of the red coats are coming, it would be the... This will take a little bit since I have to write the entire sentence. There should be a space there. Red coats are coming. Now, one important thing to remember, it is going to display the red coats are coming, but if we were to print A out later, A would still be in this form, because this command doesn't change A, it just gives us another string that is the uppercase version of A. All right, does this end with Ming? Yes, at the very end we see Ming, so we get true. All right, moving on to the next set. So 16 through 20. Does this thing start with the? No, it doesn't. This is false. It starts with capital T-H-E, but not lowercase T-H-E. If we split this sentence up based on the T's, the lowercase t's, we would split here, we would split here. What is at location 1? This is 0. This space, at spot 1, we have ES. If we were to split the next thing based on C's, these are my breakers. This is at spot 0. There is the empty string at spot 1, and then AB is at spot 2. Because we split up based on the C's. So right between these C's, we get an empty set. Let me just double check that on my key. Yep, AB. Here, if we split based on A, we get this test is E, and at spot 0, we get this test is E. So I'll write that out, even though I don't need to, because it's underlined. This test is E. What's the output of the below code? Turn this thing into a character array. Now that we have a character array, access position 3 of that character array. 0, 1, 2, 3. S. All right, we finished some more. Let's find the next set. We still got a fair amount left. Looks like we can just get these two problems in. You have a lot of questions left. I hope you get a A.2 uppercase character at position 5 on this test. 0, 1, 2, 3, 4, 5. It's an A, but we wanted the uppercase version of the sentence, so that would have been a capital A. So I hope you get an A on this. What is the output of the following code? I like cheese. Do you? A substring from 3.8. 0, 1, 2, 3. Remember, it includes the first index. 4, 5, 6, 7. Does not include the second index. Ike C. All right, now let's move on to some more questions. Clear? We can get the next two. All right. I like cheese, do you? We're going to go the entire length of the sentence, a dot length. Each time x will grow, but we're always going to say our answer is equal to whatever is at spot x divided by 2. So first we have x is a 0. Let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's an ugly 9. Let's try to make a better 9. 10, 11, 12, 13. This one's at 14, 15. This is a long sentence. 16, 17, 18, 19, 20, 21. So when x, I'm just going to do the first couple, and then I'll just finish filling it out. X is a 0. 0 divided by 2, we're going to add to answer, and we're going to add what's at spot 0, which is I. Now, x goes to a 1. 1 divided by 2 is still 0, I. Now we're going to go to spot 2. 2 divided by 0 is a space, so I'm just going to put a bar here. Sorry, a 1, which gets us space. Then we go to a 3. When we're at a 3, 3 divided by 2 is a 1. So we get space again. So it's going to do this sentence, it's going to print 22 letters because the loop is running 22 times, 0 to 21. And how it works, it does a letter twice before it moves on. Then it does another letter twice before it moves on. Then it does another letter twice before it moves on. So you could count out how many times you do it, and we're going to come up with 11 letters. So space, space, and I'll continue here. And that's C, C, H, H, E, 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 E. So there should be 22 of these, but 11 different letters. All right, that one was a little annoying. So this is a shorter sentence. We're doing a similar thing. If the thing at spot X is not a space, so we're not doing this for spaces. So as long as it's not a space, we're going to, if X is an even location, we will take the letter at spot X, but 3 more than it. So a letter that's 3 ahead of that position. If it's an odd space, so an odd index, we're going to take the letter at that index minus 2, so a letter that's 2 back from the current letter. So remember, the spaces we're not going to do anything with, but we're going through the entire sentence. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at spot 0 we have I. So we're going to actually add to the answer the letter that's 3 above it. I, J, K, L. So we're going to get a capital L. We don't do anything with the space. Now, L, lowercase, is at an even location. So we do L, M, N, O. And we get O. I is going to be at position 3. So at position 3, that's an odd position, which means we're going to go back 2 from I. G, H, I. So 2 back from G. I would actually write your alphabet down, and then you could go back and forth really easy. I had to think about that one. So it's going to be an N. I'll let you finish the rest of this one out. I don't want to make this video extremely long, but I'm going to go ahead and finish showing the answer. But again, remember, it's all about what index the letter is at on if you're going 3 ahead or 3 back. And yes, I realize this one was pretty painful. I'll try not to do one that painful on the test. But again, if you just write out A, B, C, D all the way through Z, that won't take much time, and then you can just look. Oh, what's 2 behind that? Oh, what's 3 ahead of that? Going forward's not as hard, but going backwards is, because we don't practice our alphabet backwards. All right. 25. We're almost done with evaluating the code. Cats have claws. All right. So again, the same thing. If X is an even location, we add the letter. Otherwise, we add the length minus X minus 1, which is actually going to be the one at the other end, because length is a spot that doesn't exist. Minus 1 is the last letter. Then minus X is move however far you've moved forward. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're at an even index with 0, so we add C. We're at an odd index, so we take the last letter minus 1, W. Then we're at an even index, we get T. Then we're at an odd index, we take the fourth from the end, because it's a 3, so we're at a 12. 12 minus 3 would be an L. Let me just double check that. Yes. And then the H is normal. The A is at position 5. We really have a length of 13. 13 minus 1 is 12. Minus 5 is a 7. Then we have 6, which is easy. Then at spot 7, basically we have 13 minus 7 minus 1, which is 12 minus 7, which is 5. So we get an A here. Just double checking. Then we have C, because even indexes are easy. 13 minus 1 is 12, minus 9 is 3, we get an S. Then the A is easy, the W is hard. It's going to be 13 minus 1 minus 11, which is 1. Yeah, just double checking again. A, and then S is easy because it's at an easy index. It's at an even index, not an easy index. That was painful. I think I might have 2 similar questions on the test, like this one and the last one, that are a little painful. Wait to do those till the end. All right, now let's look at practice coding. And I'm just going to turn that off, and I'm going to type my answer right here. So write a method called capital odd letters. This method will receive a string and return a string that contains the uppercase version of all odd indexes. So public string capital letters. I'm just going to be lazy. Control C, Control V, parentheses, it receives string. I don't know, A. And string B will store the answer. So we're going to say string B equals nothing. Now I'm going to do a for loop. For, and we'll return the uppercase version of all letters at the odd indexes. So for, we know we only need to do odd indexes, so I'm going to say x equals 1. X less than a dot length. And it has parentheses because it's a string. X plus plus. I'm going to say b plus equals, it needs to get bigger. It's going to get bigger by a dot 2 uppercase. I want the uppercase form of a dot char at position x. And this isn't going to work because this is the uppercase of all the letters except for the one at spot 0. X has to advance by 2, that way I stay at odd indexes. And then when I'm done, I just return my answer. Return B. Alright, let's go code for this one, val count. Write a method called val count. It will receive a string and return an int containing the number of vowels in the string. Assume all strings are lowercase. This should make your life a little bit easier. I don't know why it's tabbing over so far, but who cares? Int val count receives string A. Just trying to keep things simple. So int count equals 0. I haven't found any yet. And then we just go through the entire string. For int x equal 0, x less than a dot length x plus plus. Alright, first thing I'm going to do is store the letter, because I don't want to have to keep doing char at. C equals a dot char at 0 if C equal A or C equal E or C equal I. Come on, don't uppercase it for me. Okay. Or O. Or C equal U. That carried over to the next line, which I didn't want, but that's fine. If all that happened, then we do count plus plus. When we finally finish all of that, when the loop's done, then we return count. Should have a closing curly brace right there. I probably already had one that carried over on the next page. Nope. So again, for loop starts, count starts at 0, go through every letter. Take the letter at position X, not position 0, because you'd be checking the same letter over and over and over. I would count off if you did that. So the letter at position X becomes C. Then we see if C is an A, E, I, O, or U. If so, we do count plus plus. When the loop is done, we've done a count for every vowel we encountered, and we return it. Assume you have a string named word. Write a single line of code using Substring that will print every letter in the word except for the first and last character. So system.out.println. I need to print that out. So I'm going to use word.substring. Remember, it includes the first index. So I'm going to start at 1, not 0. And if I say, it does not include the second index. So if I say word.length, it will give me the last letter. But if I do word.length minus 1, it won't give me the last letter. So that's 1 less than the length, which would be the last letter, but it doesn't include the second location, so it would not include the last letter. Alright, write a method called first difference. This method will receive 2 strings of equal length. It will return an int that stores the first index where the 2 strings have a different character, or minus 1 if they are the exact same word or sentence or string. So public int first difference receives string A, comma, string B, and I'm going to do a for loop. I know their length is exactly the same, so I just have to say x is less than a dot length, not that it's less than both of the lengths, because they are exactly the same in length, because we were told so. If a dot char at location x is not equal to b dot char at x. Get the both letters from the given index from both words. If those are different, all we have to do is return x, because this is where we found a difference and the method's done. But if this loop finishes, it must mean they were all the same, so we return -1. Alright, I think this is our final one we have to do. Write a method called count lowercase. This method will return a string containing counter lowercase. I don't like the name of that one. This method should say receive a string and return the number of lowercase letters it has. I'm going to be lazy. I'm going to copy this one, because our video's getting close to 30. It's already 26 minutes. So public int count lowercase. It receives a string. Let's call that string A. We're going to need a counter. Int count. It equals 0. So we haven't looked at any letters yet. Our for loop will go from 0, x equals 0, x less than length, x plus plus. And then the rest of the code is going to be a little bit different, so I'm just going to go ahead and get it. If a dot char at x, and we need to say if it's a lowercase letter. So greater than or equal to single quote a single quote. And that letter, a dot char at x, is less than or equal to z. That's how we can know it's a lowercase letter. Count plus plus. When this loop finishes, all we have to do is return the count, because every time we found something in between lowercase a and lowercase z, we increase the count. All right. That concludes our review. Remember, if you didn't understand anything in this review, please come see me so we can figure it out before the test.